What are you going to learn in Codesmith's Software Engineering and AI ML Immersive program? I'm Alex, this is Sam, and we've got our top 10 skills and technologies that you're going to be learning and building with during your time in the program.
So for each of the 10 subjects, we're going to break down what it actually is, why you'll be learning it, and how you're going to be building with it in the program. And these are just the top 10, by the way. You'll be learning a lot more than what you see in this video.
Now, I want to quickly mention that getting into Codesmith requires passing a technical interview. And if you're a beginner, that might take a couple of tries. But the thing is, you're going to be building from day one of the program. So you'll really need to have a solid foundation in the basics: HTML, CSS, and especially JavaScript.
The interview covers the most important JavaScript concepts like recursion, scope and closures, object-oriented programming, and asynchronicity. It sounds like a lot, but Codesmith offers a ton of free resources to get you up to speed.
And we're going to talk more about the resources we've got to help beginners get there in a bit, but for now, let's focus on the what, why, and how of Codesmith.
First and foremost, we want to talk about our philosophy that really shapes how you'll be learning here, what we call hard learning.
Yeah, as we update and maintain our curriculum, we're not just thinking about which technologies are the most relevant, we're also thinking about the best way to guide you while still making you dig deep and struggle a bit to find the answers, because that's what real software engineering is all about: debugging, problem solving, figuring things out.
There's a reason one of the most common interview questions is, tell me about a challenge you faced and how you overcame it. Hiring managers want to see that you can take initiative and solve problems on your own. As an engineer, you're not expected to know everything. That's impossible. But you are expected to know how to figure things out. And we believe to our core that your success in this industry depends on that skill.
That's why from day one, even before you start the program, we get you into our Slack workspace. That way, while you're studying and working to test in, you can connect with other engineers to pair program, ask for help, and share resources. Once you're in, each unit lives in a GitHub repository, which you'll pull down and, using the README as your guide, work through with a partner.
Early on, it might feel like we've got the training wheels on, but trust me, with each unit, those babies are gonna come off, and you'll be doing more of the digging on your own. By the time you hit the project portion of the program, the only README you'll have to follow will be the one that you write yourself.
And I've actually got a quote here from Ruth A., a Codesmith alum and software engineer at Premier Inc. She says, "Codesmith helped me hone my ability to try out different ways to tackle problems before going to ask someone with the domain knowledge. This results in more experience and knowledge acquired in the long term." Like I said, day one of the program, you'll already know your way around JavaScript. React is a JavaScript library used to build the front end for web apps, so everything your users interact with: buttons, forms, dashboards, that kind of stuff. Now, technically, you could build all of that with just JavaScript, HTML, and CSS, but React makes the process cleaner and more efficient for you, the developer, which is great. But also, when someone uses your React app, under the hood, React uses what's called a virtual DOM to update only the parts of the app that actually change, like when a drop-down menu opens. And that has a massive impact on your app's performance. So in a nutshell, React helps you organize your code and makes the app run smoother for your users.
Tech is full of short-lived trends, but React isn't one of them. It's become an industry standard. According to Stack Overflow's 2025 developer survey, about 47% of professional developers use it, making it one of the most widely adopted front-end libraries out there. And it's not just individual devs. Major companies like Netflix, Twitter, and Airbnb rely on it too. Plus, once you learn React, it's easier to branch out into other modern frameworks and tools. Our friend Allie M., who works as an engineer for Chewy, said getting comfortable with React at Codesmith made it way easier to jump into Next.js as a front-end framework and use Jotye for state management in her current role.
Now, how are you going to actually learn it? Well, first you start with the basics. You'll be learning how the browser works and how we used to manipulate the page with vanilla JavaScript. Then you'll start with React by building a simple tic-tac-toe game, and as you get better and better, you're going to take on bigger projects where you'll learn how to manage state, use hooks, build reusable components, and you'll actually know what those words mean, I promise.
The point is, React isn't just one chapter in the program. Once you've learned how to get started, you'll be using it the whole time, especially once you reach the project phase. You'll get plenty of experience with React by building with it in apps of your own. Your React code and any other libraries you use to build the part of your app that users interact with gets compiled and bundled down to plain JavaScript so the browser can understand it. But that's only half the picture. Servers handle the heavy lifting. They serve up your code, talk to databases safely, and keep the sensitive stuff tucked away behind the scenes.
But what language do we use for that server logic? Well, you can really use almost anything, but since web developers already use a lot of JavaScript and TypeScript, wouldn't it be great to use the same language on the back end? Well, at Codesmith, you're going to do that with Node.js, which lets you run JavaScript on a server.
Node's powerful, but it can be a pain in the butt to work with, which is why you'll also be learning Express, a framework that makes building back-end logic way simpler and faster. Express gives you a set of super useful tools to handle routes, manage data, and connect to external APIs without all the extra setup and repetition.
So why teach Node? Why Express? Well, because they're built for high concurrency applications. In other words, apps where thousands of things, likes, sign-ins, posts, happen at the same time. Node is super fast and it's built to handle real-time traffic by using connection pooling, non-blocking code, caching, again, all terms that you'll get comfortable with in the program.
And that's why, according to Stack Overflow's 2025 developer survey, over 49% of professional developers use Node, and why you'll be using it too. You're going to start by learning how servers communicate using HTTP, and then as a project, you'll build your own Node server with Express, connect it to the Star Wars API, as well as your own database, and eventually create full-stack projects with both a React frontend and a Node and Express backend.
And I've got a quote here from my friend Serge V, who's a software engineer at Kindred. He told me, "I owe a lot of my success as an engineer to my ability to go under the hood of back-end technologies and get ahead of potential bottlenecks so servers don't become overwhelmed or unable to efficiently handle requests at scale. I learned this problem-solving approach in 2018 at Codesmith, and it's helped me design efficient systems, lead incident resolution, and unblock myself countless times in the years since." The filing cabinets of the internet. Now every modern app from social media to online shopping runs on data. And as a developer, knowing how to store, update, delete, and request that data is a fundamental skill.
There are two major types of databases you'll work with, SQL and NoSQL. SQL databases, or relational databases like Postgres or MySQL, are like highly organized spreadsheets. Each row represents a record, like a user, and each column stores details about that record, like email address, password, date created, and so on. SQL databases follow strict rules, and that structure is what keeps them consistent and accurate, so they're super reliable for things like financial data or user accounts.
NoSQL or non-relational databases like MongoDB are more like flexible documents. So one user's data might include name and email, while someone else's might also have a list of past orders or social posts. And that makes NoSQL great for data that changes often or doesn't fit as much of a rigid format.
So why do we teach both? Because as an engineer, you need to know their trade-offs. SQL is incredibly powerful for structured data and is still one of the most in-demand tech skills today. But NoSQL is faster and more flexible. A great developer knows when to use which and why.
You're going to start by designing your own relational database schema, writing real SQL queries using PostgreSQL. Then you'll build out a non-relational database using MongoDB and a tool called Mongoose, which lets you interact with the data using, again, JavaScript. In your group projects, you and your teams will decide which types of database make the most sense for your apps, and you'll build out your backend around it, just like the pros do. So by now, you know how to build out a user interface using React, spin up a Node.js server, and connect APIs to services and databases. That's huge. But more features mean more code and more room for mistakes. That's why you're going to learn TypeScript, a tool that catches errors before they happen and keeps your code maintainable.
TypeScript is a superset of JavaScript. Basically, JavaScript with extra safety features. Imagine you're building a house and JavaScript is a box of unlabeled building materials. You might put plywood where a strong beam should go and not really notice there's a problem until the completed structure wobbles or breaks. TypeScript is like having every single material in that box perfectly labeled. This is a load-bearing beam. This plywood is for an outside wall. That way issues are caught while you're building instead of the day you move into the house. Now, if you're trying to build a house when you don't know the difference between plywood and weight-bearing beams, you've got bigger problems. But the point is, TypeScript forces you to use the right material in the right place. It checks your code as you write it and flags problems before your program even runs.
TypeScript builds on JavaScript by adding safety and bug checking as you're building, which makes development much smoother once you get the hang of it, and that also makes it an awesome choice for big projects with big teams. According to the 2024 State of JavaScript survey, 67% of respondents stated that they write more TypeScript than JavaScript. Major companies like Tinder, Slack, and Capital One also use it, so it's pretty quickly becoming an industry standard.
At Codesmith, you'll start using TypeScript almost from day one. First, in a dedicated unit to learn the basics, and then throughout every single challenge that you undertake from that point on. Because it's baked into almost everything you do here, you'll be getting better at it without even realizing it.
Now, throughout your career, you're going to hear people say that one system is more efficient or scales better than another one, but without understanding the data structures and the algorithms behind those claims, you're kind of just taking their word for it. But once you understand the theory, you can really look at those claims and either back them up or even challenge them and actually know what you're talking about.
Data structures are ways to organize information. A stack, for example, organizes data like a pile of plates you add or remove from the top. A queue structures things more like a line of people waiting to get on a roller coaster. The first people to get into the line are the first ones to get on the ride.
And no cutsies either.
Yeah, no cutsies. A binary search tree is a data structure made of nodes connected by branches, kind of like a family tree. Each node stores a value. In the left child of a node, you always put smaller values than the parent, and on the right, only larger ones. The rule keeps on repeating at every level, which is what makes searching through the tree so efficient.
Now, an algorithm is a set of steps to complete a task, like sifting through a bunch of data. Some run faster than others. An efficient one might sort 1,000,000 items in a second, whereas a slower one could take forever. Point is, knowing how to measure and improve that runtime helps you make smart decisions about how your app should run.
Top tech companies are going to test this knowledge in interviews because it shows how you think as an engineer. But even beyond interviews, choosing the right data structure and understanding algorithmic complexity will help you build real apps that stay fast and scale smoothly as more users and data come in.
Now, before you start building at Codesmith, you'll work through units on implementing and analyzing these tools and this logic, and then you'll also use them in your projects as well as in daily algorithm challenges called hack hours. And at the end of each unit, you're going to meet with other engineers to share your logic and talk about any improvements based on that ever-growing problem-solving ability.
Almost every app you use, email, bank, favorite shopping site, whatever, starts with a what? A login screen, right? And that's not just for convenience, it's for security. The truth is, as tech keeps evolving, security only gets more challenging, which is why learning how to build secure user accounts isn't just nice to have, it's kind of the most important thing.
Now, authentication verifies that you are who you say you are. Put in your username and password, the app checks the database, and if they match, you're good. Authorization is about what you're allowed to do once you're inside. In other words, after you've been authenticated, authorization determines your level of access. For example, a regular user might be able to read and write their own posts, but an administrator might be able to delete everyone's posts. It's just about defining permissions.
These days, you can plug in tools like Google OAuth, so why bother learning authentication yourself? Because it's not just about logins. Building your own system deepens your understanding of how the front end and back end connect, strengthens your Node.js and Express skills, and gives you a solid grasp of what's happening under the hood. That way, when you're working on projects, you'll know when it makes sense to roll your own auth or when to use a third-party service like Google OAuth.
First, you'll build an authentication system from scratch with Node and Express using bcrypt for password hashing. You'll learn about session-based management, JSON web tokens, and third-party login protocols like OAuth. And after that, each project is your choice. Create your own system or use a third-party service, and whatever you decide, you'll have been equipped with the foundation to make informed decisions that you can explain later on in your job hunt. And here it is. I know you've all been thinking about it.
Pizza!
Pizza, yes, thank you, Sam, pizza. AI, the elephant in every room these days. Let's be honest, AI is changing what it means to be a software engineer. In 2025, it's not enough to just build applications anymore, but the good news is that you'll be working with large language models and retrieval augmented generation throughout your time in the Immersive.
Large language models, or LLMs, rely on embeddings, numerical representations that capture the meaning of text. Imagine a giant 3D graph with every word you can think of. Queen sits close to king, but far from water. In reality, it's thousands of dimensions, not just 3, and it maps not only words, but also phrases, sentences, even whole documents. You can give instructions to these models through prompting, basically using plain human language. And doing that well takes clear instructions, smart structure, and a whole lot of creativity.
Now, RAG, or Retrieval Augmented Generation, goes a bit further. What you do is connect your AI system to a database of your private documents like your company's return policies. So then, when a customer chats with your AI bot, the bot first pulls the most relevant information, then shapes its answer based on that.
These are quickly becoming part of every developer's toolkit. Stack Overflow reports that 84% of developers already use or plan to use AI tools, and GitHub's Octoverse 2024 shows public generative AI projects nearly doubled in a year.
Like every subject, you're going to have lectures and hands-on projects. You'll start with integrating the OpenAI API into a full-stack app that turns a user's input into SQL queries, then do a RAG project where your system queries a vector database to inform the model's response. Then you're going to join up with a team and build your own AI ML application using these technologies, and by the end, you'll have a strong foundation on how these tools work and how to use them in your upcoming projects.
A software engineer's work doesn't just end once the code is written. These days, engineers are often responsible for the whole life cycle of their software, from the first line of code to deploying it and keeping it running.
Now, DevOps isn't a specific technology, it's a set of practices that connect development teams with operations teams. In other words, the people building the app with the people making sure it's deployed, maintained, and updated. DevOps is about standardizing environments with tools like Docker, managing infrastructure, keeping communication open, and setting up CI/CD pipelines.
CI/CD is a big part of DevOps. Continuous integration, or CI, automatically tests changes to your code so they don't break your app. Continuous delivery, or CD, takes those tested changes and makes sure they're always ready to release. Continuous deployment takes it to the finish line, so as soon as an update passes, it can be automatically released to your users.
Now, why do you need to know this? Well, in 2025, even some junior roles are expected to understand cloud platforms like AWS, have a basic handle on CI/CD pipelines, and be comfortable with containerization tools like Docker.
And that's why you'll have an entire unit on DevOps. You'll build Docker images, basically packaging up an app so that it will run the same way anywhere. Deploy with AWS, and set up CI/CD pipelines with GitHub Actions. You'll get hands-on experience with the same tools, workflows, and cloud infrastructure that engineers use to keep applications running and rolling out changes every day.
Now, our friend Ellie S., an engineer with Nationwide, said, "Codesmith gave me a strong engineering foundation, but more importantly, the ability to learn quickly and make thoughtful engineering decisions, skills I use every day at a Fortune 100 company to optimize CI/CD pipelines with GitHub Actions." Now, software development isn't just about what you know, it's about what you can build. And you're definitely going to be building a ton throughout the entire Immersive program, but you need to be able to show that you've worked on something truly useful. You need something that's going to really stand out.
An open source product, or OSP, is software with source code that's publicly available for anyone to use and contribute to. At Codesmith, your OSP won't just be an app that tracks your favorite happy hours. It'll be a multi-week build where your team will design, develop, and launch a product that solves a real problem. Often, that's developer-facing, like a tool or library for other engineers. But some teams tackle challenges in other areas like AI/ML or accessibility. The point is, it's not just a final project. It'll be the highlight of your portfolio, something you can point to as proof of your skills.
How do you prove you're ready for a real-world engineering job? A resume lists skills, an interview tests knowledge, but nothing shows that you're ready like actually building a real, complex, and valuable product from scratch and being able to talk about it. Throughout your interview process, it's what most interviewers are going to ask you about, and you'll need to be able to talk in detail about your team's complex engineering decisions, problem-solving strategies, weekly workflows, all to show that you've worked to create a tool built for engineers by engineers.
It starts with a week of research and brainstorming to identify a pain point in the tech industry. The instructor team will give you guidance and feedback on your ideas. From there, you'll pitch your idea and outline the technical architecture. Once it's approved, you'll break the build into short work cycles with daily check-ins to track progress and talk things out if you're getting stuck. As you build together, you'll practice the same Git workflows professional teams rely on. And after weeks of working your butts off, your team will launch the product by publishing articles on platforms like Medium or HackerNoon, create promotional materials, and release your work to the open source community. For number 10, we've got Git, Scrum, and team workflows. This is really the cherry on top of your Codesmith experience.
That's right. As the famous saying goes, there's no I in software development. Okay, so what are Git and GitHub? Git tracks every change to your code, and GitHub is where your team shares their projects, reviews code, and collaborates. That way you can pull your work down locally on your computer, then push your changes to GitHub so your whole team stays in sync.
So what about Scrum and team workflows? Agile is a mindset for building software, and Scrum puts that into practice. Instead of splitting up to tackle things separately until the app is done, your team will work in short sprints, planning, holding stand-ups, reviewing, and refining together so progress is always clear and the project keeps moving forward.
Git and GitHub are the most widely adopted version control tools in the industry, and any serious developer simply needs to know how to use them. But this program isn't just about learning to write code and track changes. It's about working in teams, collaborating effectively, embracing that hard learning together, and simulating real-world workflows. As Titus Winters, a senior staff engineer at Google and co-author of the book Software Engineering at Google, puts it, programming is the immediate act of producing code. Software engineering is allowing collaboration across a team.
So what will that look like for you? From day one, you'll be in a team environment, pair programming, solving problems, and sharpening your technical communication. You'll also dive right into Git from the command line, pulling repos, committing changes, making pull requests, and collaborating every day on GitHub. When you hit project phase, you'll apply Scrum and follow professional Git workflows to build applications together and really get the feel for collaborative engineering. So there you have it, the what, why, and how of Codesmith.
You're going to learn popular tools like React, Express, and TypeScript, and actually use them every day to build full-stack apps in real collaborative environments. You're going to walk away not just with the technical skills, but with the problem-solving and communication abilities that hiring managers are going to be looking for. And once you graduate, you'll continue to have a lifetime of support through Codesmith's hiring program, including personalized resume and interview prep, offer negotiation workshops, and alumni networking to help you showcase your skills and land that job in the industry.
Maybe you're ready to dive in, or maybe you're just testing the waters. Either way, we've got you covered. Head on over to our website to learn more about our software engineering and AI/ML immersive program. There you'll also find free resources like CSX, our beginner-friendly JavaScript course, blog articles, workshops and events, our Slack community, and YouTube tutorials.
And if you want to go deeper before applying and learn from real people, definitely take a look at our JavaScript for Beginners and CS Prep programs too.
If you're just starting out, or even if you already have a computer science background, you're not alone. All right, enough from us. Let's get building. Click the links below or head to codesmith.io to start your journey in tech.